Hey, welcome back to another video from L&L 3D Modeling. I'm Liam, and today we'll explore how to do some surface modeling to create more complex shaped parts. To do this, we'll use a combination of different curves, 3D fit splines, the fill feature, and eventually the enclose feature which creates the part. To demonstrate all of these features, I will show you how I made the front part of this 1930 Ford Model A Sport Coupe that I've already made. This is the second lesson of our advanced CAD training for Onshape, and this will be the last YouTube video published for this course. To view our full course, please head to our website, which will be the first link in the description. Now, surface modeling isn't as complex as it may seem, and I'll show you some of the basics in this intro video. As you can see, the front part of this Ford Model A Sport Coupe isn't a very simple part. If I just extruded this out from a side view, it would be too blocky. It would not give me this nice curved shape on the top here, or this narrowing in part on the side. So allow me to show you how I made this part by rolling back to the features I used to make the front end of this car. We're going to start by rolling back to extrude 37, which is, let's see, right here. So as you can see, we've now rolled back to before I made the front end here. So let's go ahead and also show sketch 4, which is the sketch where I made the front face of what I wanted the top part of the car to look like. And let's just go down. First thing we did, making sure all our curves are visible, is I made a 3D fit spline on the side here. 3D fit splines you can make with vertices, any two vertices, or you can use edges of a part or a sketch. And you can also do this using a composite curve. Composite curves basically allow you to create a curve along any sketch entity, whether it's continuous or not, to make it continuous. And we will need continuous curves to create the parts that we want to use. So there's the first 3D fit spline here. Rolling along, I made one on the other side, I believe. Yep, there it is. And then I created an offset plane and a sketch on that plane for where I wanted the front part to be. And I created the first fill. To use the fill feature, you'll need a set of sketch curves or 3D fit splines or curves not a part of sketches that are all connected to create a surface. And as you can see, that is what I've done here. I selected the sketch part here, the two 3D fit splines on the side, and the bottom edge. You can also use the edges of parts. So I did that there. Let's see. Sketch 35 made some more edges on the bottom here to help me create some more curves, which I did here. So the next curve we'll learn about is a bridging curve. And as you can see, bridging curves can be a straight line, which is what I used here. In order to create a straight line, you select the starting vertex, the ending vertex, and you select match position for both the start and end features. So that is that curve there. Let's keep that visible. I did the same thing for the opposite side, connecting these to here. Then I made some more 3D fit splines using the sketches that I had earlier and the edges here. Then I copied the bottom part of sketch 34, and put it here. That way I could have a split spline. Then I created some more bridging curves, again using the match position. Bridging curves are a really helpful tool, again, because you can make a straight line between any two vertices. You can use match position, match tangency, match curvature, and match flow. To use a straight line between those 2 points though, select match position for the beginning and end. Let's go ahead and show those curves. So as you can see, I'm starting to set up where I want my surfaces to go. Ignore the color difference, by the way. That was so that I can create the ramble and wreck here. And then yeah, once I had all my curves set up, I could start creating fills like we did here to make the surfaces of this somewhat complicated front end of the car. So again, fill feature, any set of curves that are all connected and enclosed. They don't have to be continuous in that their tangency doesn't have to be continuous, rather, but again, they do have to all be enclosed. So that is what I did here to make this top part, and I did the same for the sides, as you can see there. And then for the bottom part here as well, I wanted this part here to be a different color, so that is why I added a bottom part here. And yeah, continued using the fill feature for all of these parts. As you can see here, continuing all the way along, again, same thing, just selecting all of the edges, making sure everything's enclosed, and that makes surfaces. And then to actually create the part, you need a set of surfaces that are all enclosed. And as you can see here, I had the top, the sides, the front, the back, and the bottom. And once you do that, to replace the surfaces with an actual part, you use the enclose feature. And again, you just want to select all of the enclosing surfaces and don't select keep tools if you want the surfaces to go away and just have the solid part. If you would like to keep the surfaces there, you can select keep tools. So I did that for this part here, as you can see, and the bottom part as well. And yeah, that is how I made the front part here. Now I'm going to show you a different part that I made that was rather complicated to make, but was much simpler after using bridging curves. Alright, so we're going to look for bridging curve 9, and we're going to roll back to there. Okay, so as you can see here, this is a more complex curve which matched the shape of what I needed to connect the part where the wheel is with the grill here of the car. So I made more 3D fit splines to make a curve that I can select for our fill feature. Go ahead and show that on here. There is the curve. You can go ahead and see the vision here of what I wanted to fill in. Made another bridging curve at the bottom, I believe. And then, after everything was fully connected, I made yet another fill for this part here, or rather this surface. But let's go back to this bridging curve. As you can see, this time it was not a straight line, or rather a curved one, and that is because I used match tangent. Now when you use match tangent, you should also select an edge so that it knows, what feature or tool you're matching tangency with. So I did that for both the start and the end, as you can see there. And yeah, that is essentially the basics of surface modeling. Use a combination of curves, 3D fit splines, and the fill feature, which then you can use the enclose feature on those surfaces to create parts out of, complex surfaces like this one here. And yeah, that is the introduction to surface modeling for more complex parts. We'll post more videos about this later on, so please visit our course. If you have any feedback or questions, please leave them in the comments. And yeah, have a good day.